السلام عليكم ورحمة الله. Here with you, Dr. Hoda Samir, lecturer Pharmaceutical Organic Chemistry, Faculty of Pharmacy Girls in Azhar University. I'm very delighted to represent my work in the 4th Hyper International Conference for Molecular Modeling. Our research, which is entitled Structure-Based Design and Synthesis of 3,7-nitro, 3-oxo, 3,4-dihydrocanoxylene 2-I-propane hydrazide derivatives as novel bacterial DNA gyrase inhibitors in vitro, in vivo, in silico, and SAR studies. And antimicrobial resistance is one of the critical challenges that have been encountered over the past years. So, a novel series of 3,7-nitro, 3-oxodihydrocanoxylene 2-I-propane hydrazide derivatives 3-6E compounds were designed and synthesized employing the canoxylene 2-on scaffold and relying on the pharmacophoric features experienced by the quinolone antibiotic canoxylene. The in vitro antibacterial activity of the synthesized compounds was assessed using 8 different gram-positive and gram-negative bacterial species, and among which compound 6D and 6E displayed promising antibacterial activity. Furthermore, compounds 6D and 6E showed minimum inhibitory concentration better than ciprofloxacin regarding the Staph aureus and Staphylococcus pneumoniae bacterial species. Also, the cytotoxicity assay result of compound 6D and 6E using the human WI38 cell line was assessed, showing their safety and selectivity. Additionally, the DNA gyrase inhibition assay for compound 6D and 6E was carried out, and compound 6D and 6E disclosed promising IC50 against the DNA gyrase comparable to ciprofloxacin. Compound 6D and 6E were further assessed via in vivo approaches, blood count, liver and kidney function, and histopathological examination. Both compounds were found to be safer on liver and kidney than the reference drug ciprofloxacin. Moreover, molecular docking studies revealed reasonable binding affinities for all compounds, particularly compound 6D, which showed better binding and stability in the DNA gyrase binding pocket than the ciprofloxacin. Also, the Swiss Adam studies revealed the bioavailability of all compounds and the GIT absorption without passing blood-brain barriers, which ensure the compound's safety. Finally, the SAR studies, or structure activity relationship studies, were established, which unveiled that not only the canoxylene main pharmacophores are important for biological activity, but also derivatization with aryl aldehydes is essential for enhanced antibacterial activity. Thank you.
Hello, I'm Dr. Fatma Jamel Abdurrahman, lecturer in the Pharmaceutical Organic Chemistry Department, Faculty of Pharmacy, Al-Azhar University. I am very delighted to represent my poster in the 4th Hybrid International Conference of Molecular Modeling and Spectroscopy. synthesis, cytotoxicity, evaluation of some novel benzochromine, benzochrominopyridine, and benzochrominopyrimidine derivative. Novel anti-cancer agents were designed to be synthesized depending on the reported anti-cancer activity of subchromine-containing scaffold, such as tolopulin, which is in stage 2 trial for treatment of solid tumors. In the current work, 2-amino-4-phenyl 4-H-benzochromine 3-carbonitrile 1 has been utilized for synthesis of various fused benzochromino-pyridine 2,2,6, which is presented in scheme number 1. Benzochromino cyclopentapyridine 7A, benzochromino quinoline 7B, benzochromino benzofluoropyridine 9, which is presented in scheme number 2, as well as 2,3 substituted benzochromine 8, 10, 12, and benzochromino-pyrimidine 11 and 13 analogues through different chemical reactions. The newly synthesized compounds were tested against 3 cancer cell lines, including liver cancer, HIF-G2, breast cancer, MCF7, and prostate cancer, BC3, among which compounds 3, 4, 5, 8, and 11 were found to possess potent anti-cancer activity against the selected cancer cell lines. The HIF inhibition investigation for analogues 3, 4, 5, 8, and 11 was carried out in comparison with cathepsin as a standard drug, where compound 8 containing benzochromino 2-yle aminobutanoic acid scaffold exerted significant HIF inhibition action that is higher than the standard drug. Thank you.
Cardiovascular protection, atherosclerosis by Said Elwi from Faculty of Pharmacy, Ain Shams University, Cairo, Egypt. Abstract: atherosclerosis is the buildup of fats, cholesterol and other substances in and on the artery walls. This buildup is called plaque. The plaque can cause arteries to narrow, blocking blood flow. Atherosclerosis is a chronic and progressive disease arising from the inflammatory processes and oxidative stress within the vessel wall. There are some drugs like curcumin, berberine, quercetin, resveratrol, and dihydrotensionone that have been shown to exhibit anti-atherosclerotic action through protection against inflammation and oxidation, modulation of cholesterol homeostasis and inhibition of platelet aggregation. These drugs are beneficial in lowering low-density lipoprotein cholesterol (LDL) and raising high-density lipoprotein cholesterol (HDL) while reducing lipid peroxidation. Animal studies in high-fat-fed atherosclerotic rabbit model have revealed that curcumin effectively inhibits LDL oxidation and decreases cholesterol and triglycerides levels. Accordingly, density functional theory (DFT) at B3-LYP 6 to 31 grams d/p level of theory was utilized to study the electronic properties of curcumin, berberine, quercetin, resveratrol, and dihydrotensionone. Calculation details: all calculations were performed using Gaussian 09 program at Molecular Spectroscopy and Modeling Unite, National Research Center, Cairo, Egypt. The molecules were computed using density functional theory at the B3-LYP 631 grams dp level of theory. Additionally, molecular electrostatic potential, HOMO-LUMO band gap energy, and total dipole moment were calculated at the same level of theory.
Synthesis, DFT calculations, in silico studies, and biological evaluation of pyrino 2,3-pyrazole and pyrazolopyrino 2,3-dipyrimidine derivatives presented by Asma Abo Elnaga Chemistry Department, Faculty of Women's of Arts, Science, and Education, Ain Shams University, Heliopolis, 11757, Egypt. The authors, Mohammed Jibril Ina, Abdelhamid Ismailo Asma Abo Elnaga Mohammed Tantor Inora, Elabi Aryan Sami Elisali. In this project, an eco-friendly approach was adopted for designing pyrino 2,3C pyrazoles from M1 to M25 via a one-pot reaction of hydrazine hydrate, ethyl acetostate or diethyl melanate, carbonyl group source, and active methylene compounds. Besides, Pyrazolo 4,3:5,6 Pyrano 2,3 D-pyrimidines M26 M31 was synthesized via intramolecular cyclization of M10, M13. Thereafter, the antimicrobial, antioxidant, and anti-cancer efficiencies of the titled compounds were assessed utilizing an assemblage of techniques. Fortunately, the vast majority of the compounds manifested auspicious biological outcomes. Over and above, in silico studies were employed to demarcate the synthesized compound's conceivable mode of action. M21 was the most auspicious antibacterial agent, while M5 was the most cytotoxic compound. Additionally, the bioinformatics study for M5 and M21 was implemented for predicting the drug likeness and physicochemical properties. Depending upon 6 characters, comprising size, MW between 150 and 500 grams per mole, lipophilicity, xlog3 among 0.7 and plus 5.0, solubility, log S6, polarity, TPSA among 20 and 130 A ring, flexibility, 9 rotatable bonds, and saturation, the sp3 hybridized carbons, 0.25. The convenient physicochemical possessions for oral bioavailability was adjusted by the produced bioavailability radar. As represented in the boiled egg paradigm, M5 and M21 do not permit the blood-brain barrier, BBB, revealing good water solubility, bioavailability, and pharmacokinetics with high gastrointestinal absorption, GI, and according to drug discovery Lipinski rule of 5, they also have good drug likeness properties deprived of any violation. Finally, DFT theoretical calculations were used to study the stability and structural parameters of the newly synthesized compounds. DFT calculations showed the energy gaps between the HOMO-LUMO energy gap with all investigated compounds in a range of 4.04 to 5.66 electronvolts, allowing for easy exchange of electrons and reactivity. By measuring the chemical hardness of the resistance to change the electron cloud density of a chemical system, it was found that M5 and M8 had the lowest value compared with the other investigated derivatives through 2.029851 electronvolts, and 2.193255 electronvolts, respectively, while M20 had 2.76034 electronvolts, with high hardness value which make it more stable, less reactive, compound. 53. Also, the chemical potentials, pi, of these compounds are in range between -4.246 to -3.0346, which indicates that the same electron cloud and the degree of absorption of both temperature and pressure is nearly the same. Furthermore, the chemical softness, the atom's aptitude for electrons accepting, was noticed in Table 12. M5, M8, M21, and M26 had values of 0.455943 electronvolts, 0.492647 electronvolts, 0.373445 electronvolts, and 0.452713 electronvolts, respectively. Many thanks for you.
The title of my research is Soft Modification of Sawdust as an Effective Agro-Waste for Promising Degradation of Brilliant Blue Dye and Amoxicillin. Abstract agro-waste such as flakes sawdust was investigated in this study for the pollution of hazardous dyes and antibiotics. Its sustainability for the synthesis nanocomposite activated carbon source has a great attention for several angles. Chemically modified activated carbon loaded with ferrocene, an atypically nanocomposite system, was successfully used in the depollution aims. The surface morphology of the synthesized sample was followed by through scanning electron microscope and XRD diffraction. Introduction. Dyes have caused damage for lungs, skin, and respiratory disorders all around the world. Direct discharge of dye containing wastewater in the environment has a potential to produce dangerous carcinogenic compound. direct and raw dye were found to be the highest level of toxicity. Antibiotics are a new class of environmental toxin that are hazards, persistent, and bioaccumulative, and potentially antibiotics have a greater drawback than the organic pollutant in the induced bacterial resistance, making treatment more difficult. Synthesis. So dust was cleaned regularly with water to remove any dust from pollutant had accumulated and dried at 120 centigrade, so dust is carbonized at three different temperatures: 300, 500, and 700. In addition to the carbonized sawdust at 500 centigrade was modified with different ratios of ferrocene. The XRD diffraction showing that activated carbon is quite similar, which carbonized at 700 is quite similar to that activated carbon which carbonized at 500, and showed that the peak at 2 theta 26.5 is disappeared compared with that for activated carbon at 500. In addition to, the average grain size is decreased than that when carbonized at 300. Ferrocene based on activated carbon nanocomposite at 500 compared with XRD of pristine carbonized sawdust at the same temperature, showing 2 theta at 24, 33, 35, 41, 49, 54, 57, 62, and 63.77, which is matched well with card number as 01072 bar 0450. Morphological analysis showing that SC2 as a representative sample, showing that the agglomerates which cavities were attributable to carbonized sawdust at 30 degree. Diffused reflectance and optical band gap analysis showing that the absorption age and optical band gap of the synthesized nanocomposite, showing that the band gap was various from 5.5 to 6.3 electron volts. Catalytic performance. The result shows that the ferrocene with 1 gram at activated carbon, which carbonized at 55 centigrade, has effective photocatalytic agent with a high removal percentage. The efficiency are 93%, 92%, and 86% for activated carbon. Conclusion. In conclusion, ferrocene with 1 gram with carbonized sawdust, which carbonized at 500 centigrade composite material, was generated using a simple one-pot technique and used to remove brilliant and amoxicillin. The most efficient one is ferrocene with 1 gram and activated carbon composite, which is carbonized at 500, were found to be increased, and the activity arrived to 97 and 93 for amoxicillin and brilliant blue respectively. Thank you.
Hello everyone, I'm Rania Badri. This poster under title Application of Carboxymethyl Sodium Copper Oxide Nanocomposites as a Sensor for NH3, H2S, and HBr gases modeling approach. As we know that semiconductor metal oxides are excellent candidates for optoelectronic devices because they have unique optical and electronic properties. Thus, inorganic semiconductors that utilize transition metal oxides like copper oxide, zinc oxide, and titanium dioxide have attracted increased interest. Recently, the detection of toxic gases has been categorized through highly explored detection techniques. Among them is the molecular modeling, which is one of the most rapidly processing areas in science that can make a connection between experimental and theoretical work. To the best of our knowledge, the sensitivity of CMC to NH3, H2S, and HBr gases have never been tested before theoretically. The main objective of this study is to study the surface interaction between CMC and copper oxide and to predict the sensitivity of the proposed structure of CMC copper oxide model molecules to the different gases H2S, NH3, and HBr. All calculations were carried out using density functional theory as implemented in Gaussian 09 package at Spectroscopy Department, National Research Center. Model molecules representing dimer CMC and its nanocomposite are subjected to optimization at the B3-lib LAN L2DZ level of theory. In building our model molecules, 2 units of CMC are supposed to interact with 1 molecule of copper oxide. The interaction of copper oxide with CMC was supposed to be throughout the oxygen atom of the metal oxide and the functional group of the polymer. Thus, as we can see from figure 1, that the proposed structure of CMC contains 8 active sites. These active sites are the hydroxyl group attached to the different carbon atoms and the C-double bond O group, and finally the O linkage along the chain of the CMC. Additionally, the interaction between copper oxide and CMC can be occur throughout complex interaction and adsorbed interaction. As we can see from table 1, that the total dipole moment of the complex interaction increases by changing the position of the interaction. Meanwhile, HOMO-LOMO band gap energy values changes by changing the position of the interaction. And we see that the position named P3 has the highest total dipole moment and the lowest HOMO-LOMO band gap energy. Meanwhile, for the adsorbed interaction, we observe the same sequence that the total dipole moment changes by changing the interaction site, and the HOMO-LOMO band gap energy also changes. And by comparison, these two tables shows that the most interaction mechanism will be that occurs throughout the adsorption interaction, as it has the lowest HOMO-LOMO band gap energy, which means that the most probable interaction to occur. Additionally, the sensitivity of the proposed structures of CMC and copper oxide to the H2S, NH3, and HBr gases are also studied in terms of the total dipole moment and HOMO-LOMO band gap energy as presented in Table 3, as the reactivity of the different structures is closely related to the band gap energy between their HOMO and LOMO orbitals. At that point, the higher the reactivity, the smaller will be the band gap and the lower will be the stability, and the total dipole moment will be the higher. Also, this figure indicates that, this table indicates that the reactivity of the CMC copper oxide structure increases as a result of the interaction with the different gases, which means that the proposed structure of CMC and copper oxide can be used as a gas sensor for NH3, H2S, and HBr gases. Hello everyone, I'm Rania Badri. Our poster today will be about highly sensitive hydrogen sulfide gas and methylene blue dye sensors based on carboxymethyl cellulose, sodium, and copper oxide zinc oxide core shell, a DFT study. As a result of the rapid industrialization, which has resulted in a growth in the quantity of harmful and dangerous gases in the atmosphere, the environmental pollution has lately reached an alarming level. As a result, creating sensors capable of detecting hazardous and dangerous pollutants is important. Zinc oxide nanoparticles are one of the most significant and functional materials due to their wide band gap. However, they are only active in the UV region. Thus, a variety of methods including doping, surface modification, and the creation of composites have been used to enhance the sensing performance based on zinc oxide to make it active in the visible region. Thus, coupling zinc oxide with semiconductors having narrow band gap is one technique to boost its photoactivity under sunshine. Thus, in this study, Time-dependent density functional theory calculations were carried out for the optimization of copper oxide, zinc oxide, and copper oxide, zinc oxide core shell structures. The major aim of our study is to enhance the sensitivity of copper oxide and zinc oxide by making a core shell structure, and to study the sensitivity of CMC copper oxide, zinc oxide core shell to H2S gas and to methylene blue dye. Figure 1 shows the optimized structures of copper oxide, zinc oxide, and core shell structure. As we presented that in Figure 2, copper oxide and zinc oxide have sharp peaks at 675 and 324 nanometer respectively as a dominant transition, which is shifted to 1000 and 262 nanometer for the core shell structure. The large shift in the absorption peak confirms that the molecular structure of copper oxide was changed due to the formation of zinc oxide layer. Table 1 shows the maximum absorption wavelengths and the optical band gap energy of the three structures. As indicated in the table, that the optical band gap of copper oxide, zinc oxide core shell structure is lower than that of copper oxide and zinc oxide, and this is due to the formation of the localized states within the band gap. Based on our previous work, it is concluded that metal oxides can interact with CMC throughout the hydroxyl group of CM2. Accordingly, there are two possibilities for the interaction of CMC with the core shell structure. The first interaction mechanism occurs via the hydroxyl group of the CMC and the oxygen atom of the shell. However, the second interaction mechanism is that proceeds throughout the metal atom of the core shell structure as presented in Figure 3. Table 2 presents the total dipole moment values and the HOMO-LOMO energy for these two interaction mechanisms, and it confirms that the interactions proceed throughout the oxygen atom of the shell is the most prominent one, as it has the lowest HOMO-LOMO band gap energy. The sensitivity of CMC copper oxide, zinc oxide core shell structure to H2S gas and to methylene blue dye. As we can see from Figure 4 that there are different positions for the interaction of the H2S gas and methylene blue dye with CMC copper oxide, zinc oxide core shell structure. Table 3 and Table 4 presents the obtained values of the total dipole moment and HOMO-LOMO band gap energy for the CMC structure core shell interacted with H2S at the different positions and with the methylene blue dye at the same positions. It's clear that the values of total dipole moment and HOMO-LOMO band gap energy different by changing the position of the interaction, which means that the proposed structure of CMC and core shell structure is more sensitive for the H2S gas and methylene blue dye. Our conclusion is that as the total dipole moment of CMC and copper oxide zinc oxide structure increases and the HOMO-LOMO band gap energy decreases upon the exposure to the H2S gas and methylene blue dye, it can be concluded that the proposed structure of CMC and the core shell may be a promising material for the detection of H2S gas and methylene blue dye. Thank you.
Poster number 41, molecular modeling and biological activities of metal oxide modified bioactive glass, presented by Taha Taima. Bioactive glass was prepared by sol gel method following composition 60 silicon dioxide, 34 calcium oxide, 6 P2O5, where X equal 10 from Fe2O3, copper oxide, zinc oxide, and germanium oxide. Samples were then studied by FTIR and biological activities of studies sample were proceed with bacterial test. Model molecules for different glasses composition were built in calculated with density function theory at P3 lib 6 31 PD level. Some important parameters such as total dipole moment, molecular electrostatic potential based infrared spectra were calculated. Modeling data indicated that before of O10 vibrational characteristics are enhanced by addition of silicon dioxide, calcium oxide due to electron rush uh, resulting along wall crystal. Additional zinc oxide to B4O10, silicon dioxide, calcium oxide had high impact on vibrational characteristics. On country of other alternative, copper oxide, iron oxide, and germanium oxide that had lower change in spectral index.
Cadmium sulfide semiconductor materials has dielectric band gap 2.4 electron volt and has several applications in high efficiency solar cells. Recently, cadmium sulfide doping with magnetic metal transition element is called dilated semiconductor materials. In this paper, we prepare cadmium sulfide doping with manganese by chemical methods and can study the structural properties and the dielectric properties to use in several applications such as digital recording media. From figures, we can confirm the structure of cadmium sulfide by EDX technique and obtain cadmium sulfide is nearly stoichiometry. And also we can study the formula transformation infrared technique and can confirm that cadmium sulfide is formed by doping manganese in cadmium sulfide. The dielectric properties is improvement. From figures, we can study the AC conductivity and dielectric constant and electric modulus. And we can obtain the target from this paper that the dielectric parameters are enhanced to use in different applications such as promising applications and data storage service devices. Thank you.
Spectroscopic studies and antibacterial activities of 11H indino 12B كينوكسالين 11 أون. القائمين بالبحث: داليا أنسي، دكتورة هبة متولي، دكتور أشرف السيد. Introduction. تصدر البكتيريا infectious disease, photo spoilage, corrosion of industrial materials and much more. ومن المشكلات العالمية التي نواجهها هي البكتيريا المقاومة للأنتيبيوتيك الناتجة من excessive use and abuse of antibiotic. العديد من الأدوية والتفاعلات الكيميائية المهمة للبيولوجي تحتوي على الهيتيروسايكليك كومباوند. وجود الهيتيرو atoms or grouping of frequently imparts preference specificities in biological reaction. كينوكسالين هو أحد المويتز التي جذبت الانتباه مؤخرا due to its growing significance in the field of medicinal chemistry. The goal 11H indino 12B كينوكسالين 11 on has been tested for its toxic effect on Salmonella typhimurium, Klebsiella pneumoniae, and Bacillus subtilis, and has been investigated in depth theoretical study to structure and spectral properties. Result: the antimicrobial activity of tested compound. The compound have been examined against gram-positive and gram-negative bacteria بتركيز 20 ملي by Wells diffusion method, and inhibition zone was measured and recorded. MIC of tested compound. We have two definitions, MIC and MBC. MIC is the lowest concentration of antimicrobial inhibit the visible growth of bacteria, but MBC is the lowest concentration of antibacterial agent kill particular bacterium. The MIC value and MBC value was measured and recorded in the table against Salmonella typhi, Klebsiella pneumoniae, and Bacillus subtilis. Compound resistant variant.
In case of Salmonella typhi and Bacillus subtilis, figure A and C, the bacteria show no resistance against the compound with all dose. But in case of Klebsiella pneumonia, figure B, the bacteria show resistance at the 5th day with 1 ICMMS dose. Computational study, the quantum chemical calculation study of our compound at function PLY3B6311 G was performed to explore the structure and spectral properties. والنتيجة geometrical parameter and NMR spectra. geometrical parameter باستخدام الدف توضح إن المركب have bond length and bond angle وكانوا very close to the X-ray reported value with deviation موجودة في البوند with different color 0.1 and 0.7 angstrom وبالتالي the dihedral angle data show little deviation 175.12 and 3.70 while the X-ray value were 179.99 and 0.02. NMR spectra في توافق ما بين calculated and experimental proton NMR with deviation 0.21 to 0.43. For example, the calculated proton 1 and proton 6 present at 8.17 and 7.84 بينما experimental show at 8.51 and 8.08 and the carbon 13 calculated show in range 125.78 to 197.29 with average difference 2.32 to 7.98 while the experimental in range 122.29 to 189.31. This research examines the antibacterial activities of our compound. In vitro, the antibacterial activities of the compound were carried out against the culture of bacteria. The compound showed remarkable antibacterial activity. The comparison between calculated optimized structure geometry and spectral data, proton NMR and carbon 13 NMR with experimental data display acceptable agreement. Thank you.
Antibacterial effect of mycosynthesized nanosilver against multi-drug resistant bacteria. النشر بواسطة ندى حسني غزالة ومساعدة كل من الدكتور أشرف السيد Botany Department Faculty of Science منصورة University ودكتور محمد عثمان عبد المنعم Botany Department Faculty of Science بنها University. Introduction. Multi-drug resistant bacteria are a serious and increasing health problem. Therefore, there is an urgent need for the development of other cost-effective and efficient antimicrobial agents that overcome antimicrobial resistance. Nanotechnology can be a very promising approach in this problem. Nanotechnology is the process of creating particles that are in the nanometer range between 1 and 100 nanometer. Microorganisms have been explored as potential biofactors for synthesis of metallic nanoparticles such as cadmium, sulfide, gold, and silver. Silver nanoparticles have inhibitory effects on the growth of bacteria, virus, and other eukaryotic microorganisms. The aim of this study to search for an effective antimicrobial agent against the multi-drug resistant bacteria. A result, mycosynthesis of silver nanoparticles. Figure 1, the growth of Fusarium oxysporum in MGYB media A before B after. Figure 2, fungal cell free filtrate with silver nitrate before and after incubations showed in picture C before and picture D after. Characterizations of silver nanoparticles. Figure 3, UV spectral scan from 350 to 500 nanometer of mycosynthesized of silver nanoparticles indicates a characteristic peak at 438 nanometer. Figure 4, scanning electron microscopy. Silver nanoparticles were almost round shaped of size less than 100 nanometer. Figure 5, 10 micrograph of microsynthesized of silver nanoparticles. This image shows spherical or oval shaped of nanocolloids with average size 6 to 15 nanometer. Figure 6, this micrograph of the selected area diffraction pattern for 1 nano silver particles revealed that silver atoms which appeared as light spots were present in the diffraction ring. Figure 7, the value of zeta potential of silver nanoparticles minus 17 MV indicates the stability of the nanosilver. In addition, the conductivity, which is 0.1, indicates stability. Figure 8, ATIX spectra of silver nanoparticles. The optical absorption peak is observed at 3 keV and the weight percent of silver as 70%. Table 1 showed the MIC of silver nanoparticles on microbial growth, Staphylococcus aureus and Klebsiella pneumoniae. The concentrations which total inhibitions of the bacteria is 10 microgram per ml. Table 2, the inhibition zone of silver nanoparticles and the antibiotic on Staphylococcus aureus and Klebsiella pneumoniae. The inhibition zone of silver is larger than the inhibition zone of an antibiotic, so the inhibition zone is the largest when we make mixtures with silver nanoparticles with an antibiotic. Ultrastructure of that treated multidrug resistant bacteria by TEM. Figure 10a, changes in Klebsiella pneumoniae cell structure observed by TEM with or without silver nanoparticles. Figure 11b, changes in Staphylococcus aureus cell structure observed by TEM with or without silver nanoparticles. Molecular characterizations of the treated multidrug resistant bacteria by rapid analysis of DNA isolated bacteria treated Staphylococcus aureus and Klebsiella pneumoniae with silver nanoparticles that showed by present or absent the bands. Protein binding profile of the treated multidrug resistant bacteria. Protein profile with silver nanoparticles is the first line MF protein ladder. C1 is the control of Staphylococcus aureus and number 1 is the Staphylococcus aureus with silver nanoparticles. C2 is the control of Klebsiella and number 2 is the Klebsiella with silver nanoparticles. New bands are denoted by a black arrow, while bands that have disappeared are indicated by a red arrow. Analysis of the multidrug resistant bacteria's protein binding pattern after exposure to silver nanoparticles, which indicated that there are 28 bands totally of 7 monomorphic, 13 polymorphic bands and 8 unique bands. Conclusion. This study has shown that silver nanoparticles have significant antibacterial effect on multidrug resistant bacteria regardless of its susceptibility to antibiotics. The data presented in this work are novel, so it could lead to new advances in development of antibacterial agents that could overcome the multidrug resistant. However, further studies have to be conducted on the toxicity level and possible adverse effects that could arise in the use of silver nanoparticles as an effective antibacterial agent in the healthcare system.